week 2 assignment, or actually a week 2 lecture. Just so you've got a lecture for ITS 410. Kind of again, just trying this. I'm going to put this one in the front of the class so you kind of got it, and let me know if this is helpful to you or not. So we're basically going to kind of go through how to query numeric data from MySQL tables. You'll see a copy of the lecture already set up for the week 2 critical thinking walkthrough. That will be a link off in this one as well. But again, the only thing is making sure of what you've got is that there's a lot of MySQL data types that are basically broken down into number, date and time, and string. String is text characters, so A, B, C, D, D, or 1, 2, 3 as a number, as a text, not as a number. Right, so that's one of the things to think about, is that if you're doing string types, so sort of like 4270 golf is considered a string, where 42 plus 70 is considered numeric. So it depends on how you're operating it as well. You can go into the LinkedIn Learning that you've got here for what are data types and the key differences between them all. Right, so the good part, numeric data types. These are all numbers, and they all come in specific sizes. And this is one of the things to kind of remember, is that when you're building out your database and you're trying to figure out how big you're going to have something do, right, you're going to have it be a certain size. So if you are going to do social security numbers, right, medium int is perfect because it's 9 numbers and your social security number is 9 digits. Right, so you could do that perfectly, and then you're using all the space in your column, and you're not wasting any space in the database. And that's really what all this was about, especially on some of these earlier numbers. You know, if you always want the last 4 of their social security number, that's a tiny int. Now, I'm using a social security number as my example, but I would definitely go ahead, if I have someone's social security number, I would encrypt the heck out of this database, right? Because if I have someone's social, that is PII, personally identifiable information. It's keys to kingdom kind of number. It's one that you definitely kind of want to keep secret. If you're doing other things along the way, like integers, floating, anything else like that, you know, you've got a certain max that you can do. So it can kind of limit what you're doing in terms of math. You're not going to be doing high particle energy physics. But, you know, for most business cases, that's actually pretty straightforward. You don't have to worry about how big your column can be or anything else. Part of the constraints around some of these earlier data types and earlier ways of doing things was that, you know, space on a computer was limited. Space and a memory was limited. And we don't have those constraints now. So you can really sometimes just go for it, but you also want your database to be efficient. So you should try to get as close to your width as you can, so that you're really just not wasting space or having your database look through a bunch of white space that isn't basically there, right? So we've got our 4 types, right? We've got our integer, fixed point, floating point, and real numbers, right? And these are basically used, integers are basically whole numbers, right? No fractionals. 5 integer types. They differ only on the scale of the values that they present. So math, right? So you have to remember whole numbers, you have to remember fractions, you have to remember decimals, you have to remember time, right? And all those other things. So those numbers will include all things, including decimal points, scale, position of the decimal point, and everything else. So 0 means no decimal point. And again, it's kind of part of that, how that goes, right? Common use of integers, right? Primary key, column set, right? Integers are easy as a primary key, especially depending on what you're primary keying on, right? If you're doing it as a user, a customer ID, if you're doing it as a student ID, then yeah, that makes perfect sense. Primary key is a tuple, right? And that tuple is that intersection of column and row, right? That tuple is you. It's an interesting word. It's a word you won't see very often until you get into some really good arguments with your database administrator. But tuple is that intersection of the column and the row, right? And it can be a thing. Primary key consisting of multiple columns cannot have a null value, right? So if you're actually going to do user ID, customer name, customer address, that as your primary key, it all has to be filled in such a way that it's useful to the computer and meets the requirements for that. A table can only have one primary key. The cool part is you learn about foreign keys later on, where you can marry the different primary keys in different tables across the board, right? A special type of integer is auto increment. By default, it will auto increment by 1, but you can actually change that to 5 or 10 or 100. Most people just keep it as 1 just because it's easier, don't have to worry about it. But that If you're doing self-service sign-ins, that customer ID can be that auto increment integer, and that just makes it easy. You're not having to worry about running over or trying to have two of the same values or anything else. So it really does just make it easy, right? So we create table terms, term ID, auto increment primary. So basically what that means is that we're going to have a text character, right? We're going to have an item ID, right? And it's an auto increment primary. So that means that it's going to be an item ID that's going to be a number, and it's going to auto increment by 1, and it's going to be your primary key. And then your next column is item text, and it's going to be a character, variable character, so it can be numbers and letters. That will be 50 spaces wide. So you can have a good size product name or item name for that item text. Note that both the integer and int and integer mean the same thing in the create stable. So you could use int, you could use integer. And on this one, insert into table terms, term ID or term text, values, laptop, desktop, server, fiber channel. So, right, so you can actually specify what you want that to look like, and then go through the process of actually entering them. You don't have to actually do these. The actual critical assignment's a lot easier, so I would follow these around. But it's just kind of that neat process where you're going into how you create table items, and then how you can insert, right? You're going to be doing a lot of inserts later on, and how that works for creating tables and doing stuff. Decimals are pretty easy. Decimal, fixed number, or just numeric. And again, numeric is just something that we don't have to worry about. Precision, that's significant digits, and that's important when you're getting into math, you're getting into physics, or you're getting into anything else that requires math. D, decimal point. All right, values of D are from 0, means that a table can be p digits long with decimals, right? Decimal fixed. So we have cost decimal 512, so its precision is 5, decimals at position 2. And that's really all there is to it. That decimal is probably never going to change from decimal position number 2, right? It's always going to be the second one in there. And then you go through and you can check and see variable characters 124. Remember, varchar is numbers and letters. Increment primary key. Cost decimal is going to be precision of 14 with your decimal at position 4. So you can have some pretty good expensive items in there. And that's really all it is. And then you can select everything out from that. Zero fill is kind of an interesting comment. It just means don't fill in, don't pad. It's an interesting thing. You rarely ever will use that. Date and time. Date and time is actually kind of neat. Date and time is great. I've used date time, especially when we're building out databases for one of the major cities here on the West Coast. When we wanted to make sure if someone paid their traffic ticket, were setting up a court database, and we had to have date time perfect so that that customer actually got a receipt back that showed over the internet when they paid their traffic fine. And then if they ever, if something ever weird happened and the police showed up, they could show the receipt and say, oh no, I paid it at this date and time. So this was really important when you're doing things like traffic tickets, courts, anything that requires a date time stamp. Another time we did date time was when we were working with the National Institutes of Health and working on their thing that they do to get money, their grant process. We actually use date and time, and sometimes these grants would differ by seconds, and they'd be perfectly good, but we needed to take it all the way down to seconds, right? And then timestamp those bad boys. So we had it. Do watch your LinkedIn Learning on date and time types, because those are kind of fun, but they really are used. They really are important. Date timestamps, date time columns, are important for proving or doing a thing that something actually happened at a specific date and time, or that you were able to get first in line or something else. You can also do some interesting things that has to do with time zones, but date time stamping is really important. Strings, these are all characters, characters from 1 to 255, fixed, variable length. Fixed, most of us use variables now. Very little of it is fixed. So it's all going to be varchar. Blobs are fun. Binary large object. Remember that word. Blob. Binary large object. Those are great for pictures or anything else that's a blob. You can use it for keys. You can use it for just raw digital data. You can use it for pictures. You can use it for audio, video, and all that kind of stuff. Most of that going to be big stuff, right? But it's easier just to point off to a link, rather than actually trying to store a gigabit size video in your database. That's kind of rough. Tiny blobs, tiny text, right? Anything that's 255 characters or anything else. Mediums, and then text, right? So these are huge. These are things for like blog entries, big, huge pictures or anything else like that. But there's better ways of doing it now in terms of just storing a pointer or a link to that, and then enumerate that list of items, and then make a standard set, math, this set of distinct items. Within that, you can actually make sets. You do have a LinkedIn Learning for this as well, so that will kind of make it go well. It's kind of neat to see how you can do different things with strings and all the rest of it. Strings are not necessarily easy to do math on, but there are ways of doing things, and it makes it interesting. So when you're making your char type, you're making your variable character, your character type, you specify in that how many characters you want it to be. So if it's char 15, it's 15 characters. If it's char 255, it's 255 characters. And again, your big thing though is make sure you don't have a lot of white space. You're not just wasting space in the database. So if you're just going to do first name, last name, the common first name, last name, is going to be about 100 characters long. Honestly, because we're dealing in an international environment and we're dealing with some really interesting character sets. There's no reason why I can't have someone from China sign up for my service. There's no reason why I can't have someone from Saudi Arabia sign up for my service. So I need to accommodate that, and you need to think about those things when you're doing your databases nowadays, and that it's not just all one thing, but what is the average length of a username, or what is the average length of a person's real name, and kind of build those into your database when you're looking at your characters and all the other things that go along with it, right? So character 3, that could just be, your initials. Boom. Most of us have 3 names. Some of us only have 2. Some of us have 10. So, right, depending on how you want something like that to be, think through your case study and your use case on this when you're going through it. You can use comparison operators: equal, greater than, or equal than. All right, so that's a big thing. You do have some MyWikiBook here that you can also take a look at in terms of how that works. Wikibook's okay. And then again, select star from table items where X equals whatever, right? And again, these are all just pretty straightforward on how to do things as you walk through your character types. Again, I'm more of a variable character type because I'm a letters, numbers kind of person. These are great for passwords. Passwords should all be variable character, username, password with numbers, letters, special characters. So these are all going to be variable characters. And if you do use it as a password, you're going to encrypt the heck out of it. You will never use that password again. You'll use a hash between the two, and then you can do all the other things because MySQL will truncate data if it doesn't fit. It will just drop everything after that. So if you do things, you can actually tell it to do that. So like when you get that error, oh no, wait, I told you 8 to 32 characters, you can actually set those minimums and maximums as you go through that whole process when you're building out your password thing. Then again, retrieving data, basic, straightforward, select from, where, order by, limit. These, you're going to be working with these all the way through this whole process. So one from is actually really neat. We did that in Mark 2, select star from, telling it what table I wanted to do, and all the rest of that is really easy. You're going to use that a lot. Determines conditions. So if I wanted to have a product name that started with Gib, so I wanted all my Gibson guitars, so I would do select product name from products where starts with GIB, and then star, just because I want everything that starts after GIB. You can order it by, you can alpha or numerically order it, and then you can limit return. On some of the queries you're going to do later on in this class, you're going to return hundreds of rows, and just limit it to the first 10, right? So it'd be limit 10. And that's it. That's the whole command, limit 10. And that's all you got to do. You don't have to return all hundreds of rows. I just need to see that it works. So just go ahead and limit it by 10, and we should be pretty well good to go on that one. I think that's it for this. Hopefully you found this lecture useful. Again, we're going to try to experiment with this one. So if it's not useful, let me know. If it's useful, let me know. But hopefully this gives you something to listen to while you're hanging out, in your car or on the bus or cooking dinner, or you just want to be quiet time on the sofa and plug this into your cell phone. Do let me know though. All right. Thanks guys. Talk to you next week.